So we are going to discuss electrolysis. Electrolysis means basically the term electrolysis consists of, let's suppose, let's suppose electro and then lysis. Electro and then lysis. Electro means electricity, and lysis means breakdown. Lysis means breakdown. So you can break down the compound by passing electricity. So this process is known as electrolysis. Why we are going to break down any compound? Why we are going to break down any compound? So basically, uh, sometime let's suppose if I have sodium chloride, in this you can see there is a chlorine. So I'm telling you that I need chlorine. So you have two options. The first option is that you can purchase from the market, and another option is that you can do electrolysis and you can separate chlorine from the sodium chloride. So chlorine is used to kill bacteria. It's also used in the swimming pools to kill the germs, microorganisms. So so this is the advantage of doing electrolysis, that you can obtain like your required metal or any of the non-metals. So uh, also if I need oxygen gas, so you have water. So if you're going to break down this water, so it would be giving you hydrogen gas and oxygen gas. So you can obtain oxygen gas from the electrolysis of water. This is the purpose of doing electrolysis. You can also break down the compound by using heat. By using heat, that is called thermal cracking, like pyrolysis. But obviously, some metals are very reactive, so they form a strong compounds such as sodium chloride. Sodium is very reactive, it's from group 1. If you
Mm-hmm.
remember, we have discussed periodic table, so I told you group 1 and group 2 metals, they are so much reactive. So they cannot be separated very easily. So in the end, we would have to do electrolysis to separate the chlorine from the sodium atom. Okay, so that's the reason that we do electrolysis. So the process, the process in which the process in which compound is broken down, compound is broken down by passing electric current is called electrolysis.
Okay.
And if you are going to do electrolysis, so what are the apparatus that you need to do electrolysis? Obviously, if you are going to cook something else, so you need some sort of, you can say containers. Let's suppose you need a spoon, you need some sort of like a bowl, in that you can cook any type of food. So same goes with electrolysis. If you're going to do an experiment, if you're going to do electrolysis, obviously you need something else to do electrolysis. So that is known as the apparatus that you need to do electrolysis. So the first thing that is very important to do electrolysis is container, is the beaker. Beaker means that it's the container in which I would be putting my sample. Let's suppose in this case this is sodium chloride and it may be water. So we would be doing electrolysis. So the first thing that we need, that is called beaker. That is called beaker. You know, beaker is also known as electrolyzer. electrolytic cell. Electrolytic cell. The second thing that we need is wires. Wires. The third thing that we need is battery, is also known as the power source. Is also known as the power source. Okay. And
Okay.
the next thing that we need to do electrolysis is uh, electrodes. Electrodes.
What? Electrode?
I would be telling you each and everything that we need electrodes, and also we need uh, you can say electro electrolyte. We need electrolyte. Okay, so if we are going to have these things, so we would be assembling these all together, and then we would be doing electrolysis basically, right? So how can we assemble this? How can we assemble this? Basically, this is your beaker, let's suppose, which is also known as electrolytic cell. This is the beaker, like the container in which you are going to do electrolysis. And then you have this. This is the wire. And then you have electrolyte in it. And so this is your battery power source. This is the wire, and this is electrolyte, and this is your cathode. This is your anode. It's the positive terminal of the battery, and it's the negative terminal of the battery. So we would be assembling this all apparatus in this way, and then we can do electrolysis basically. In this case, the electrolyte is, you can say, sodium chloride. So you must know each and everything. Okay, obviously, what is electrolytic cell? What is electrolytic cell? So you can define electrolytic cell in simple words. You can say this is the beaker. This is the beaker in which you are going to do electrolysis. Like let's suppose if you need some glass of water. So I'm bringing the water for you. So obviously I would be bringing the water in a glass. So glass is a container which contains water. So same goes with electrolysis. In this beaker, in this container, we have some sort of solution, some sort of liquid, through which we are going to break it down by means of electricity, which is also known as electrolysis. So we can define electrolytic cell as it is the cell which converts electrical energy into chemical energy. Like, what do you mean by this? Let's suppose I have this sodium chloride and I am providing electricity to the sodium chloride. So it would be breaking down into this and this. So I have provided electrical energy. I have provided electrical energy. And after providing electrical energy, it's broken down into the cation and an anion. So I can say that the electrical energy is converted into the chemical energy. So you can say that this is electrolytic cell. So I'm going to define it that what is electrolytic cell? Electro electro then lytic and then cell, which converts electrical energy into the chemical energy. And what is electrolyte? And what is electrolyte? Electrolyte. Electrolyte. In this case, electrolyte is sodium chloride or it may be water. So the solution which conducts electricity.
Sir,
Yes,
for electrolytic cell, is it the beaker? Which,
exactly. Yes, this is the beaker.
yeah, is it for the like pink sentence? Is it the beaker which converts electric energy into chemical energy? Is that it?
Oh, yeah.
Okay.
Okay. So the solution which conducts electricity, it may be any of the solution. It may be sodium chloride, it may be magnesium chloride, it may be water, it may be anything else. And also, you know that all the ionic compounds are a good conductor of electricity in their aqueous state or in their molten state. And also, some sort of covalent compounds are also a good conductor of electricity in their aqueous state, just as hydrochloric acid, HCl, H2SO4, HNO3. Okay, so these are good conductor of electricity in their aqueous state, although they are covalent compounds. So, any of the compound, any of the solution, any of the chemical, any of the substance that is the good conductor of electricity, you can say that this is called electrolyte. You cannot say that the solid sodium chloride is an electrolyte. Why? Because if you remember, in chemical bonding, we discussed that in the solid state, ionic compounds are a bad conductor of electricity. Can you tell me why ionic compounds are bad conductor of electricity in its solid state?
Because in the solid state, there's no like free moving electrons allowing to that charge
Ye-
pass through them.
yes, basically whenever I ask like the conductivity of any ionic compound, so you are supposed to refer the number of ions, not the number of electrons. There is a difference between the conductivity of a solution and of a metal. Let's
Okay,
suppose we have a lot of metals, sodium, magnesium, silver, copper, iron, gold, a lot of metals we have. So they all are good conductor of electricity due to the movement of free electrons. But whenever you are going to talk about ionic compounds, so you know in ionic compounds, in their aqueous state or a molten state, they have free ions. So you would be writing the reason for the conductivity of ionic compound that they have free ions. So they have free ions, and you know that in solid sodium chloride, it has no any free ion, no any free ion because it's in the solid state. And you know that the ionic compounds have a giant ionic lattice structure. So in a lattice structure, all the ions are held together with a very strong electrostatic force of attraction, so that I can say that the ions cannot move due to the very strong force of attraction that they join together. So that's why in the solid state it's a bad conductor, but in the liquid, in its aqueous solution and also in the molten state, it would be a good conductor because in the both state, the ion would be free to move. That's the reason I'm saying that any of the solution or any of the compound which is a good conductor of electricity, I can say that is an electrolyte. Okay, are you
okay,
getting my? Yes. And then you have electrodes. Electrodes, basically electrodes on which redox reaction takes place. Redox reaction take place. It may be oxidation and it may be reduction. So on the basis of this, I'm going to further classify electrode into, there are two types of electrodes. Number one is cathode, and
And
number two is anode. Number one is cathode, and number two is anode, basically. Okay. So, cathode means the plate, the metal plate, or any of the surface, the surface should be a good conductor. Remember, the surface should be a good conductor. Let's suppose you know that diamond is a bad conductor of electricity. Diamond is a bad conductor of electricity. So how can you say that we can make an electrode by using a diamond? How can you say? How can you say the diamond is like we can make electrode through the diamond, because the diamond is a bad conductor of electricity. So remember, just as electrolyte, it should be a good conductor of electricity. So we can make electrode by using copper, by using lead, by using any of the metal, and also electrode can be made of the graphite. Graphite is also a good conductor of electricity. Am I right? Yes or no?
yes.
Why graphite is a good conductor of electricity?
Okay, so graphite is a good conductor of electricity because of the wait, it's like in a layered structure of wait.
Graphite has free electrons. If you remember the structure of graphite, in the graphite, each carbon is connected with the three other carbon atoms. How
Okay.
many electrons are there in the outer shell of carbon?
Um, there is four.
So in graphite, each carbon is connected with the three other carbons. The fourth electron is free.
Mm,
So that electron would be responsible for the conductivity. Okay, so graphite is a good conductor.
all right.
So we can make an electrode by the graphite. And I can say, okay, it's a negative, it's a negative plate. Why it's a negative plate? Because it it's connected to the negative terminal of the battery. Negative terminal of the battery, and it's a positive plate which is connected to the positive terminal of the battery.
Okay.
Yes. And also you can say on the cathode, a reduction takes place, and anode, oxidation takes place. So I can say red cat,
Sorry, sorry. What does plate mean? What does it mean by plate?
like any of the surface that is connected to the negative terminal of the battery, like any of the surface. It may be made of graphite, it may be made of copper, it may be made of any of the metal. Just I made this, I have drawn this just like that.
Yes.
Reduction occurs at cathode. Anox, oxidation occurs at anode.
Okay.
Okay. Then let's suppose, after understanding these all the things, now the thing is that I have a compound, I have a sample, and I'm going to put the sample into this electrochemical electrolytic cell, and I'm turning on the battery. So what would happen basically? First of all, let's suppose I'm taking this. This is in the liquid state. It may be in this state. It may be this.
Okay.
Just wait. Okay. So if you have sodium chloride liquid and you are going to pass electricity, so it would be breaking down and would be giving you this and this. And if you have solid, so nothing would happen. And if you have this, it would give you sodium plus and Cl minus. And obviously it is aqueous. What is aqueous? What is aqueous?
Yeah, that's so. I was about to ask you what's the difference between liquid and aqueous.
Okay, liquid means
And
that I have melted the sodium chloride at a higher temperature.
yeah,
It's
and
just the molten state. And aqueous means I have dissolved sodium chloride in water. I have dissolved sodium chloride in water. So
oh,
obviously, if you're going to pass electricity through the sodium chloride aqueous, so along with the sodium chloride, water would be breaking down as well and would be giving you this and this. So this is the main concept that you need to know. That what would happen if I'm going to pass electricity through the compound. Okay.
okay.
Hmm. What do you think if I have this and I'm passing electricity? If I have this, if I have this, and if I have this, and this. Yes. What do you
Okay.
think?
So, wait, do I say what state they're in?
Basically, you are supposed to tell me I'm passing electricity through these all the compounds. So, what the product that I would be getting after providing electricity? This is the main question.
Okay, so for for iron chloride, you would get iron, which is positive, and the plus chloride negative. Is that correct?
You need to mention the charge as well, like how much the charge is.
Yeah.
-1, -2, -3, +1, +2, +3. You need to mention this.
Okay, so would it be for iron? Would it be -3 or
It's +3. It's a metal. Metal is always having a positive charge. This is the concept.
okay? And then for aluminium, it would be aluminium +3,
Okay,
and then oxygen -2,
good.
and then for magnesium, it would be magnesium +2,
Okay,
and then plus nitrogen -2.
nitrogen
-3.
-3.
Yeah.
Because this number representing this and this number representing this.
Yeah,
Okay.
because swap and drop, yes. Um, so magnesium oxide would just be magnesium plus and then plus oxygen negative.
So how much is the negative and how much is the positive?
Just one.
No, it's 2 plus and 2 minus. They are
Oh,
going to cancel each other. That's the reason there is no any number.
yeah.
Yes.
Yeah, so yeah. Okay. Um, so so sodium would be just plus, and then plus oxygen to negative.
It's 2 Na plus. Okay.
But then oxygen's
2 minus, right?
yeah.
Okay.
Wait, sir, why is it 2Na plus?
Because it's Na2O. So you have in a compound You have two sodium atoms and one oxygen atom. Okay,
Mhm.
that's why.
Okay. Oh, and then so magnesium chloride, it would be magnesium plus 2, then chlorine just minus like yeah, so just minus. Wait, no, it would be 2Cl minus. Is that correct?
Okay, so it's Mg2 plus and
No.
2Cl minus.
Yeah, yeah, yeah,
Mg is 2 plus, remember, because
yeah,
magnesium is in group 2, so that's why the charge is plus 2.
yeah. Yeah. So so it'd be Ca 2 plus and then 2Cl minus.
Good.
Okay.
Okay, then obviously, after having these charges, so then what we are supposed to do after having these charges, right? Let's
Mhm.
suppose, let's suppose this is the apparatus that we would be having during electrolysis. So I'm going to take this and I'm going to put sodium chloride liquid in this as a sample. Sodium chloride liquid as a sample. Obviously, when you are going to turn on the battery, so you're going to pass electricity through the sodium chloride liquid. So afterward, you would see that sodium chloride would be breaking down to give you sodium plus and Cl minus. You would see a lot of ions in this beaker, a lot of ions. I'm going to write only one, but obviously there would be a lot of ions that would be present in the same beaker because you have taken 1 mole of sodium chloride, and you know that 1 mole of anything contains how much particles, how much atoms. So a lot of cations and a lot of anions we would be having in this beaker after breaking down the compound by means of electricity. So then what would happen? This is the main concept. After breaking down, then what would happen? As you know that opposite charges
And
attract each other. Opposite charges attract each other. So you know that this is cathode. Cathode is having negatively charged. Anode is a positive.
yes.
Initially, initially, initially the
Wait, sir, isn't it the other way around? Cathode's positive and
no,
anode.
cathode is negative and anode is positive. Okay,
Oh,
cathode is negative. It's inverse. If you're thinking that cation is
yeah,
positive, so the
that's what.
cathode is negative. So it's
Okay,
it's inverse basically.
all right.
So cathode is negative and anode is positive. Initially, it has no charge. Initially, when you haven't connected this plate to the terminals of the battery, so it had no charge. It was neutral. But when you have connected these plates to the terminals, so obviously they got the charge. So the plate which is connected to the negative terminal is called cathode, and the plate which is connected to the positive terminal is called anode. So then Cl minus would go towards anode and Na plus would go towards cathode. Are you getting me?
Yes,
So then what would happen when Na plus will go towards cathode? Cathode has a lot of electrons. It would gain 1 electron. It would form Na solid. Cl minus, obviously it's going towards anode. Anodes have a positive charge. Cl minus would give its electron to the anode and would become neutral. You know that it's a diatomic gas. So I would be writing 2 and 2. In short, I can say when we did electrolysis of sodium chloride, so we got sodium metal that was deposited at the cathode and chlorine gas is formed at the surface of anode. So what I observed that greenish yellow gas were produced at the surface of anode. So what do you mean by the greenish yellow gas, or you can say yellowish green gas?
chlorine, chlorine.
So it indicates that the chlorine is produced.
Yes.
And also, you would see there would be the increase in size of the cathode. Why? Because the sodium would be deposited at the surface of cathode.
Yes.
So this is the purpose of doing electrolysis. In the end, you have separated sodium solid and also chlorine gas. Okay, got it? Okay,
So wait, let me one sec. So
okay.
chlorine, and then we wait. Two E is electrons, and then
E
the
is electron, yes.
okay plus.
As you know that this equation is for cathode and this is for anode.
Wait for the chlorine at the very end of anode. Is it liquid?
Yes.
Okay.
Reduction and oxidation.
All right.
Reduction means gain of electrons. So Na plus is going to gain electron.
And
Na
oxidation.
plus is going to gain electron. Na plus is going to gain electron. So that's why it's reduction. And Cl minus is going to lose electron. Cl minus is going to lose electron. So that's why it's oxidation.
So
Okay.
when it gains an electron, it becomes solid, right?
It becomes neutral basically. It becomes in the its solid. It's in its standard state.
Oh,
And
okay.
the standard state for the sodium is solid.
And when
And
it
obviously, a standard state for the chlorine is a gas. So that's why it would be forming gas. And you would see yellowish green color
okay,
at the surface of anode. Okay.
okay, all right.
Whenever there is a gain of electrons, so you are supposed to write an electron on your left hand side, and whenever there is a loss of electrons, you are supposed to write electron on your right hand side. So this is the difference. So if you have an equation and you are going to identify whether this equation is reduction or oxidation, so you can see electron. If the electron is on the left hand side, so you can say this is reduction, and if electron is on your right hand side, so you can say this is an oxidation. Okay,
Okay. Yeah.
yes. So if I have this, first of all, write down all the equations like at cathode. First of all, you need to write this equation, how it would be breaking down, and then reaction at cathode and then reaction at anode. Yes.
So okay, so the reaction at cathode would be Al Al Al, and then it would be +3, and then plus E minus. Then it goes to, and then it becomes aluminium solid. So that's cathode, and then oxygen would become O minus 3, O minus 3, and then it goes into electron minus plus oxygen gas. Is that
Okay. No, first of all, you have to form this equation, and then 3 oxygen would be produced. Oxygen is having -2 charge.
oh
Then this aluminium would go towards cathode, would gain 3 electrons, would form aluminium metal that is solid, and this O2 minus would lose electron and would form O neutral. But you know, oxygen is a diatomic gas. It should be 2. It should be 2. If you are going to write 2 over here, you are supposed to write 2 over there, and you are supposed to multiply this electron by
2
4 by
4.
4
Yeah,
like by 2, so it would become 4.
yeah,
So this is an electrolysis for aluminium oxide. After doing electrolysis of aluminium oxide, you would be getting aluminium metal and oxygen non-metal.
sure.
Yes.
So the first like line, Al2O3 becomes 2Al3 plus, and then 3O2 minus. How would it be? Why is the 2 and the 3 at the very front? Why is there a big 2 and the 3 at the front?
So you're asking that why this is 2Al?
And yeah, and why is it 3O?
This is Al2. So that's
Yes?
why it's 2Al. It's three
Okay.
oxygen. That's why I have written 3 oxygen.
Okay.
Charge is something else and the coefficient is something else.
Oh,
Coefficient is 2, but charge is 3 plus.
okay. Oh, yeah.
Yes, okay. Then a lot of compounds we have, you need to break them down, and then you would be having, like, you would be writing equations. Reaction occurs at cathode, reaction occurs at anode. So you need to write these all the things, okay?
Mm.
Yes.
Wait, sir. Why would for anode on the sodium chloride, why would the big 2 be in front of chlorine?
Why would what?
There would be a 2 in front of chlorine. Oh, wait, is it because it's NaCl2?
No.
Why is there?
Basically, it's NaCl. When I have written equation for anode, so I got to know that chlorine is diatomic. So automatically I have written this Cl2. So obviously then you need to balance this equation. So I have written 2 over there and over there. So that the equation may be balanced.
Oh,
So
okay.
that's why this is the reason. Okay.
So chlorine is diatomic. Okay.
Exactly. Okay.
Yeah.